Okay, welcome to class. So today we're going to talk a little bit about precipitation and how it actually works. There's only really two things that we need to look at this. So we're going to try to keep this short. I really don't want to make these long. Like I said in the last video, we'll try to keep these short. If we can, we'll try to keep it around 30 minutes or so. And this one might be a little bit shorter, but we'll just wait and see. So let's talk about precipitation and how it forms. So the first thing we want to look at here is this funny picture I have here. Isn't this the way we feel sometimes when that rain comes around? Sometimes we feel like we're getting drowned like this cat is in this picture here. Okay, so precipitation. Let's take a look. First of all, we want to take a look at what precipitation is. And so what you see right here is you're going to see this great big raindrop. This one down the lower portion of it right here, this is a raindrop. And this is your typical raindrop, which is about 2 millimeters in size. This is a pretty good scale to show you what's going on here. So if this is our regular raindrop, then all these other drops that we see up here, those are going to be our typical raindrops. So we have like our typical drops, which are right here. Then we have a larger drop up here. And then we have right up here, which is mostly what we call condensation nuclei. And some of that is just super teeny. You can hardly even see it even in this picture here. That is the stuff that is like pollen, dirt, other things that actually can cause things to condense onto them. Smoke, I mentioned in class, bits of insect wing, or just even bits of insect, all of that stuff. Water cannot condense onto things or can make a raindrop unless it has something to condense on. So we need this condensation nuclei up there, and a lot of it is just really, really tiny. The most popular one out there is salt, and salt is hygroscopic, which means it loves water, and so it actually seeks water. And we get lots of salt from the waves in the ocean when they crash along the shoreline. We get that salty mist that comes up and it fills up our atmosphere with salt. Okay, so when we look at these things, we're looking at all of this stuff that you see here. This is mostly just cloud material. And now what we have down here, this is our actual raindrop that's big enough for gravity to pull it out. Okay, so the first part we want to talk about is called the Bergeron process. And the Bergeron process is a cold process. So this would be about like snow, sleet, hail, some of that stuff here. So let's take a look at the Bergeron process and how it actually works. So if you see right here, we have all of these little water molecules that are moving around all over the place. And then we actually have all of these other particles, these cloud droplets. Now, these are not big enough to fall. That's what's making that cloud. Remember how I said in class that they start to condense and light has a hard time passing through or filtering through those things? Well, that's the cloud droplets that we see right here, these bigger circles. In the midst of all of that, we will, if the temperatures get cold enough, now you need to realize that in order for water to freeze in a cloud or even in the upper atmosphere, the temperatures for pure water and it's suspended in the air, has to be at least or close to negative 40 degrees Celsius or Fahrenheit, because it's the same number. So we've got really, really, really cold air up here. So we have that little tiny particle, that condensation nuclei, and that water starts to condense on there. As it condenses, it can start to freeze. Partly because it doesn't stay into this spherical shape, but when it falls onto that particle, it can actually flatten out and increase its surface area. And by increasing its surface area, it actually releases heat, and it can actually freeze. So if we see down in this next little area, that particle starts to freeze, and all these other little droplets that we see in this area here start to collect and collide into that snowflake, or that little bit of snow and ice, or that ice that's sitting in the air. When it does that, that water hits it and it flattens out and increases its surface area, which then it releases that heat and it begins to freeze. As it does this, what's going to happen is that this snowflake right here ends up growing, and it gets larger and larger, and we see this bigger snowflake right through here. Okay, and that's where we get that snow crystal. This is how snowflakes form, and this is called the Bergeron process. Now, I was walking out one day, and I happened to run across some fog. This happened earlier in the year, and it was really cool because I was actually able to film this. And so what I want to show you, I just want to back out of this and show you this video clip that I made. I am walking around in the fog, and what you actually are seeing, this is fog. If you don't look at it with the light, it just looks like fog. But actually, when we turn on the light and look at it, you'll see these little ice crystals here. So if you're wondering what I'm doing, I have been walking in the fog. There's a house right there, and it's really foggy. But the one thing I think is really kind of cool is that you can actually see the individual drops that are making up this cloud. Now these drops are really small, and they're too small to actually fall to the ground. In order for water droplets to fall to the ground, they have to be at least I believe 2 millimeters, and then they can start falling. But these are so small they don't fall, and all they do is sit and float around. You can see right there. I don't know how well you can see that, but kind of cool. This is what it looks like in a cloud. So it's cold enough that they're freezing, and these are just individual little ice crystals. And I thought I'd just share this. It's kind of cool to see this. This is what is known as the Bergeron process, where you have these little ice crystals that form, and as they move around, more fluid or more water attaches itself to each one of these crystals, and they grow bigger and bigger until they're big enough to fall, which is how we get snow. Now, I know you probably cannot see this. It's super hard to see, but I wish you could see this a little bit better. Some of these are actually big enough that they're falling. Super hard to see this. I know it's so blurry. But every once in a while you'll see, I think you can see it right there towards the top of the screen. You can see bigger ones that are falling and other ones that are not. The bigger ones have got enough mass to them that gravity can pull them out of the atmosphere. Right there. And the other ones just keep floating around because they're just too small to fall. So as I'm looking up in the sky here, if I can get that again, and the wind is starting to pick up and everything's moving a lot faster now. And it's just a really light breeze. I mean, I can hardly even feel it. But it's enough to really start pushing these things around. If I move with the wind, you can see it a little bit better. And when I stop, it goes crazy again. Anyway, and I would share that with you. It's kind of cool to see that in actual real life. Let's take a look at collision coalescence here. Now, collision coalescence is a little bit different. This is a warm process. Okay, so when we have things that are going to precipitate out of the air. We have cold processes that are going to provide snow, which I just showed you, and that's called the Bergeron process. Or we have a warmer process, which is called collision coalescence. And what this is when we actually have water droplets that collide into each other. So let's take a look at this right here. We're going to take a look at each one of these. And this is the process that we look at when we go down and we go from the very beginning to the very end. So let's take a look at that first little part here. So these are your typical cloud droplets, all these little tiny ones here. And then this one here is just starting to get big enough that maybe it starts falling a little bit more. It's probably not going to fall to the ground, but it's definitely heavier than the others. And as that starts migrating and moving through that cloud and moving around, just like those other little pieces of ice that I showed you in that last clip, they're going to start colliding into each other, or they're going to have collisions. And that's what we see right here. So we see that we have, right down here, we see the typical cloud droplets, and then you can see right here that they start colliding into these other little rain droplets, and they start getting bigger and bigger and bigger. And once we can get them up to about 2 millimeters in size, then gravity will actually start pulling those out, as long as there's not a strong wind that pushes them back up into the air. Let's take a look at this next one. So now we have our actual rain that's starting to fall, and as it falls, it's going to start accumulating even more and more, and we're going to coalesce all of these little rain droplets out here, or these cloud droplets, into this bigger one right here, and then we end up with this nice, great, big rain droplet. Now, one thing to know, most rain when it falls is not any bigger than 4 to 5 millimeters. It doesn't get any bigger than that because, as you can see in this picture right through here, we kind of have this nice little bean shape. Well, what we have is we have air that's coming in and pushing up, right up against that raindrop. And as it does that, we get to a thing called terminal velocity. So now as this rain starts falling down, air starts pushing this up, and it's going to make a little tiny pocket underneath there, and it's going to push upward. What happens is that this raindrop will actually explode into smaller pieces. So you can see as we're coming right through here, it's falling down, it's getting bigger and bigger and bigger. It's still coalescing, but then it bursts and breaks into smaller drops. These smaller drops, what they'll do is they'll collide into other ones, and they'll coalesce into all these other little small little droplets here, and they'll form bigger and bigger raindrops. Okay, now if you do get hit by a raindrop, you might think it's a lot bigger than that. Chances are is that it formed this great big raindrop here right before it hit you, and it didn't have enough time to break into a little one. So those bigger drops have not fallen very far. They just barely formed as you got bombarded by it. So I want to show you another little video clip here. Let's take a look at this. We're going to go ahead and take a look. This is an actual footage of collision coalescence. This is what we're talking about. So we have this rain that comes down, it starts to fall, and as it falls, air starts, you're going to watch, it's going to inflate, and poof, it just blows up into a whole bunch of little teeny tiny raindrops. And then those are going to fall, and we end up having a lot more collision, and we start coalescing this water together, and we start getting more and more raindrops that form. Kind of cool to see this. This is it. This is what we call collision coalescence. And this is really how rain forms in the sky. Okay, good. So let's take a look at this next scene here. And let's take a look at some of these profiles. So we're going to look at profiles for rain, snow, sleet, and glaze. Let's take a look and see what happens in the sky and how these things form, because really they're all the same thing. What matters is what are the temperatures like as they are falling down through the sky. So let's take a first glimpse here at rain. Rain, more than likely, is always going to start out as snow. When we get really high up in that sky, we've got some cold, cold, cold temperatures, and it is going to form as snow. But if we look right over here, we can see the profile here. This side over here represents the cold, and this side over here represents the warm. So if you can see, that rain begins to fall, and when it gets down to about right here, you'll notice that the temperatures change. So now it's out of the freezing zone. So as that rain starts to come down, we can see now it's in warmer air, which is going to keep things in a liquid form. So a lot of rain, when it falls, actually starts out as snow and ends up as rain, because when it gets down to here, that snow begins to melt and falls down on top of us. You can actually tell how far away that is by how cold the rain is. Have you ever had a July day and it's raining and the rain that falls on you is really cold? That's probably because right before it hit you, it just melted from snow into rain. So most of your rain is going to start out like this, unless it's a really low cloud, then we might have some rain from here. But those higher end clouds, those summer clouds, more than likely are going to make snow before they actually make rain. You remember in my last video I told you that hail only is formed in the summertime and it's not made in winter, because those lower clouds are just they're too low. They don't have enough vertical development to cause that hailstone to form. So we've got these really high clouds in the summertime, which we can get that vertical development and get those hailstones to form. So let's take a look at this next one. Let's take a look at snow. This one should make a lot of sense. If we have snow, look at the profile here. This thermal profile, when we look, you'll notice that it just never ever goes into warm air. That means that from the ground on up, it's just too cold for water to melt. So when we have snow, that snow falls and it stays frozen even when it gets all the way down to the ground right here. Pretty simple. Snow is really pretty easy to talk about. But now let's get into something else here. Let's talk about, well, I forgot I had this in here. Here's some nice pictures of some snowflakes, those six-sided snowflakes. These are the actual crystals. And this was a picture taken through just some different imagery. And yeah, they say that it is true that there are no same snowflakes. And I still kind of question that, but I mean, all the billions of snowflakes that fall, they say that there are none, but I'm sure there's at least one that's similar. Maybe not identical, but similar. Let's take a look at sleet. So what in the world is sleet? Sleet is that rain that comes down, and if you look at the rain, it has a little bit of slushiness to it. So it kind of has, it's a wet slushy, I guess, like a slushy you get at the store, or 7-Eleven, Slurpee, or whatever it is. It is not just rain, and it's not just snow, it's a mix. So let's take a look at the profile here. So we have the cloud that's right up here, and we end up with that snow that starts to fall. When we look at the profile here, take a look. So we have nice cold air, and then it warms up. We get into this warm area, and it comes down over here. And what I really want you to do is look at the length right here, okay, for how far it's in the warm. But then what happens is it comes out, and it starts to cool back down again. So we have snow, gets down into this warmer region, it starts to melt, but then it gets back down here and we start getting that cold air again. And that cold air will cause that rain to freeze. But the one thing is that it's probably not going to completely freeze altogether. So we're going to start getting this lumpy, slushy mixture of rain and snow, or maybe even like little bits of hard pellets in there. If you've ever been in sleet before, you'll know what it is, because it's not very fun. It's not very comfortable. I remember being on a four-wheeler and had a plow, plowing the snow, and it was snowing, and then it's got warm enough that it started to turn into more like a sleet. And my face, it was like hitting my face. It just hurt. It stung. Not only were you getting hit by these little tiny pellets, but you're also getting cold because there was a wetness to it, and that water is really, really cold. So sleet is not very fun. I don't like being in sleet. I don't know anybody that does, but it is not very fun. Okay, so I want to look at this last one here. What is the difference between sleet and glaze? The biggest thing is going to be, I want you to take a look with the two here. So I have snow that's right here. Watch how far the snow comes down when we get, well, yeah, the snow will come down when we get in the glaze. Let's see the difference here. So I'll move forward here. Take a look. So we come down here, and you'll notice that I'm going to jump back here. There's a little bit of a difference here, okay? So we come back here, we get into the glaze, and now we're down about right here. The difference over here in time really doesn't change a whole lot. Okay, it might be just a little bit longer in the warm with glaze than it is in the sleet. But so here's what happens: we get the stuff, the snow comes down, and it melts. But then it comes down into this nice cold area, and it doesn't actually freeze. So we don't get any pellets in there. We just get super cooled water. Super cooled rain. Now when we have super cooled rain, what that means is that that rain is so cold, it's ready to freeze, but it just doesn't quite do it yet. And there's one way we can get it to freeze. And I like to, you'll understand what I mean like this. Have you ever been laying in your bed and it's nice and cold and you're all wrapped up in that blanket and you're in bed and you're retaining all that heat. But the minute somebody comes around and rips that blanket off, all of a sudden you get spread out and all of that heat is just gone and you immediately get cold. Well, welcome to glaze. You have that water that falls down and it is super cold. It is ready to freeze, but it's not quite there yet. And when this raindrop falls down as glaze and it hits, it's going to spread out. And as it spreads out, it's going to thin out and flatten out, which is going to increase that surface area. And once you do that, it allows that heat to just be released. And once it releases, bam, that water will freeze. Okay, this is what we call glaze. And it does that. If you ever think about glazed donuts, you have that nice glaze over the donut. Well, this is the same kind of thing, but it's going to glaze everything else. So this is what a glaze is. Let's take a look here and show you a picture of glaze. Glaze is when we have, you can see all these power lines, and you can see trees, you might even see cars where people, you probably see some videos on this, you can go on YouTube and see this stuff, but people roll down their windows and it looks like the window is still up. It's because they have the sheet of ice on there. Some of you who watched the video that I mentioned with, I can't think of his name, Richard Hammonds. They actually do this when they actually freeze the side of a building and break the wires. They get this glaze to occur. So what happens is this glaze comes down and it lands on trees. And it comes out as water. So it just spreads and covers everything and then it freezes. So we get leaves, plants, all different kinds of things that are out there just get glazed over. You can even see this stop sign right here. See icicles. I bet the whole front of that is just covered in ice. This car is probably covered in ice. And one of the dangers with this is that we end up with black ice. So a lot of places that get a lot of glaze typically shut things down when we have glaze. It's just super dangerous to be out there, and a lot of times you can't even get in your car. Some of you have been in those areas and you know what it's like. It's not very fun. So when we say, yeah, they shut things down just for a little bit, they have good reason for it because it is super slick. Okay, so let's take a look here. This is something here that I wanted to show you. I didn't really show it to you in the clouds, but this is a form of precipitation that actually happens here in Utah all the time. It's called virga. So this is virga rain, and you can see this actually, I would dare to say you could probably see this all summer long, especially in the late afternoon. You get these nice clouds that form in the heat of the day and in the late afternoon, and then they start to actually rain. You see all these little trails that come down, all these little tails down, that is rain. But the problem is that when this rain comes down, it gets down to a certain point and it starts warming up and then it evaporates. And it is rain that evaporates before it actually hits the ground. Utah is the second driest state in the nation, and we see this all the time. Check it out. Summertime, you see these clouds like this, it's raining. It's just, it doesn't hit you. And it could be happening right above you. You can actually see it. If you're lucky, maybe it will come down and get you. Chances are it won't. Let's take a look at how hail forms. Okay, and I want to show you some hail. And I've talked about this before. Here's another image of a cloud with hail. So this is what we'd call that, if you remember, a cumulonimbus cloud. cloud with a lot of vertical development on here. This is the top part of here, which hits the top of the troposphere, or the troposphere and the tropopause. Here's where the lifting condensation level is. So we have all of these updrafts that come out, that come from the bottom up. And then we have this nice little particle up here, right over here, that we could have this hail that just starts forming. It's just a little tiny piece of ice. Well, that thing's going to come up and down and up and down and up and down. And as it falls, it's going to, it might melt, or it will definitely accumulate some more ice on it through the Bergeron process. And if these drafts are strong enough, they'll push that particle way back up into the air again. And it will keep adding shells onto it. And it will have, it's like a gobstopper, an everlasting gobstopper jawbreaker. It just keeps adding shells on top of it and on top of it and on top of it. Until what happens is that it gets right up here and it starts to fall. And the wind is not strong enough to push it back up in the sky again. And so what happens? It falls down through the downdraft here. And so we get this section right through here where we see a lot of hail. A few things about hail. Well, let's take a look here. Here's a nice hailstone. This is a massive hailstone. It's way bigger. These things probably not going to see a lot of them. But this is a nice image of this because you can actually see the center right here. And then you see these rings. And every ring is where it may have fallen and went back up and fallen and went back up. And so it melted, froze, melted, froze, melted, froze, and it kept going through this. I'm not 100% sure on this. You know, they say when you look at the rings of trees, you can tell how old it is. I'd have to do some research. Maybe one of you guys can do some research and answer this for me. But I wonder if there's a correlation between the rings and how many times it went up and down and up and down and up and down through this process. This is a massive hailstone. This is something you definitely don't want to get hit. And obviously, hailstones cause a lot of damage. Okay. We have all of these broken windows, cars are dented, buildings are damaged. Here's a little bit of information for you. A hailstone is the size of a golf ball that falls out of the sky, travels at least 100 miles an hour. So picture getting hit by a hailstone coming out of the sky the size of a golf ball at 100 miles an hour. Definitely going to cause a lot of damage. Okay, so let's take a look at this. I'm going to back out of the frame here just for a minute, and let's take a look at some of these things here. So the first thing I want to show you right up here is mist. Okay, mist, you can see mist, drizzle, and rain. Okay, these three right here, you'll notice that they are all liquids. Mist is something that you typically will not actually, you probably won't see it. It definitely won't fall like rain does. You walk into it and then all of a sudden you end up having, well, I don't know what else to call it except for mist. Okay, it's super small. You could feel them because you feel wet, but you're not actually going to feel raindrops. In fact, I thought the last time I read is you can tell between a drizzle and a mist is mist. If you have rain puddles on the ground, mist will not actually interrupt the puddle. So if there's no movement on the top of the puddle and there's mist, the water as it comes in contact with that puddle won't actually cause ripples or anything else. That's one way you can tell if you have mist. Drizzle, on the other hand, will. Drizzle is small enough that you can actually get it to drop, but they're going to be very, very, very small. And it can last for several hours, especially in places that, like Oregon and Washington, where it normally is always wet. You're going to see drizzle there all the time. And some of that drizzle, now I've been in places in Oregon where it's been a mix between a drizzle and a mist, where I've been driving my car down the road and I've actually had to turn on the windshield wipers to wipe off all the rain or all the water off my windshield because it was getting so wet. But there was no rain. It was just that the air was so saturated with water. So we start out with mist is the very smallest, then we go to drizzle, and then we can go right to rain here. So when we get to the rain, we're looking at anything between 0.5 and up to 5 millimeters. Okay, that's about how big it gets. Remember, if it gets any bigger than 5 millimeters, more than likely it's going to break up as it falls down. I don't think I need to go into any more details with rain. Most of you know what rain is. Sleet, on the other hand, so now we're going to get down in from sleet on down. Now we're getting into all solids here. So sleet, I already told you, sleet is more like a round spherical slushy. It says here in this, it says that it is a lumpy ice particle. Okay, it's gonna be a little on the wet. Fat. Some of you go to the store and you go and get a fountain drink. Some of you like the little pelletized ice, and some of you like the big stuff. Well, that pelletized ice, when it gets nice and wet, it kind of becomes a little more crunchy and slushy. That's going to be more like your sleet. Your glaze, on the other hand, your glaze is, when it does hit, it will freeze. So I know they say that's a solid here, but we're also, you got to realize that this is going to be a raindrop that freezes on contact. So as it falls, it is not ice, it is actually a liquid. And when we have that liquid, that glaze, and when it hits, it instantly freezes and starts to coat and glaze things. Rime is probably one of my very favorite things out there. I love rime. Rime is really cool, and I'm not talking about rap or anything else like that. I'm talking about the stuff that you see when this fog comes in, it's wintertime, and you look at all the trees and they have frost all over. A lot of times also known as hoarfrost. It's beautiful stuff. And typically you can actually see rime, you can actually see which way the wind was blowing, because the rime actually creates these little tiny feathers, and the tip of the feather will point to the direction where the wind was blowing. And I have an image here of some rime that I'll show you after we get done with the rest of this. Snow is not a big deal. You should know what snow is, but I will say this, that there are differences of snow, and most of you are aware of this, that we say here in Utah that we have a dry snow, and you leave and go out maybe to the East Coast, where maybe like New York or Illinois or anywhere around there, and they have a wet snow. So the difference is in that snowflake and how much water is available. So if we were to go back and look at those images of that snow as it falls down, those little droplets around that snowflake, here in Utah, we have very few droplets because the air is really dry. And so what happens is when they do collide, it allows that snowflake to grow really big. But since there's not very many snowflakes, it's not a very dense snowflake, and it usually is very feathery and light. Then when it falls, it is kind of more dry. It's not wet. You can go out with a broom and sweep it off. You can probably even go out with a leaf blower and blow that stuff off. But if you go back to New York or Illinois or these places that have a lot of little droplets in the air, because the air is really humid, well, when that snowflake falls, it collects a lot more water, and it tends to fall out faster. It doesn't grow those nice big flakes like we have here, some of those great big feathers that we see. And when it falls, it is more dense and it is very wet. It's not very fun. If you've ever had to shovel that snow, you'll know what I'm talking about. Talk about backache. It is heavy, heavy, heavy stuff. This stuff we have around here, not bad at all. It's actually really pretty nice. Okay, so let's look at the next one here. Let's go to hail. I already showed you hailstones. I showed you what hail is. Okay, they can get really big. We've had humongous hailstones, and places that are really highly populated tend to actually have a lot of problems with hail and death. They don't have the infrastructure to be able to protect people. A lot of people, those hailstones can go through buildings, they can go through other objects and actually cause a lot of death. I think in India they actually had the death rate was really high because of so much hail. Maybe I have it here. Let me take a look and see. Okay, here we go. Let's take a look at some of my notes here. So let me give you a little bit about hail here. Okay, so usually we can get them anywhere from like this size of a pea, or it can be high, bigger. Obviously, it can get bigger. We can get up to hail or golf ball size. We don't see those as much, but they do happen. Not around here a lot, but you probably see them back in the Midwest. Okay, We've even had some as big as oranges and apples and some of those things that are that size, baseball, softball size hailstones. So let me give you a few little statistics here, or just some little facts about hail. Of what's happened. So back in 2003 in Nebraska, June 22nd, June, okay, a 7-inch wide chunk of ice was recovered. So 7 inches, that is, holy moly, that's probably what, the size of some of your shoes, I guess. Some of you have bigger feet than that, but 7 inches, we're talking about a massive hailstone. In 1970, in Coffeyville, Kansas, a 5.5-inch diameter hailstone fell out of the sky, and get this, it weighed 1.67 pounds. And that is pretty incredible. From 1987 to 1990, and from 1987, 90 people in Bangladesh were killed because of a hailstorm. 90 people. That is in one shot. That's a lot of people to die from a hailstone. And I already told you this little fact here, is that when we have hailstones the size of golf balls, they can actually fall at a rate of 100 miles an hour. Okay, another one I want to show you here is Grupple. We get a lot of Grupple here. Or Grapple, sorry. It is really pretty cool. I call it Grupple. Some people call it Grapple. You decide what you want to call it. It's really cool. Have you ever had Dippin' Dots before? Well, Dippin' Dots are a lot like this Grapple here. It is really cool. You'll see it. It looks like hail, and some people will call it soft hail. It looks like a hailstone, but it's more like styrofoam. We get it here in Utah a lot. What it is that we have a little piece of ice that goes way up high into the sky, and as it falls and comes back down, it collects other snowflakes around that. And we actually get glaze on there too, and freezing rain, but it becomes really airy and not very dense. And so when it falls, it hits the ground. It is just like getting pelted with styrofoam balls. Really pretty cool stuff. I think I've got a video here. So what you see behind me, this is Grapple. Let's take a look here, and this is actually a video of it. You'll see that it's not heavy like hailstone. In fact, when you look at it and you take a look at it, you won't see any rings in it. It just looks like somebody clumped up a bunch of snow, or a bunch of little tiny snowflakes, and that's really what this is. Just a bunch of little tiny snowflakes clumped together. They're not painful. They're actually kind of fun. We get this a lot here in Utah, and it's pretty interesting. This is rime. Rime is my favorite. I love looking at rime. Okay, you see all these little needle things right here, so you can see how it comes up and it comes to these nice little points, and we see all these nice little needle or portions up here, especially right through there. Okay, that is rime. I'm not sure how this picture was taken, but I do know this, that the wind had to be blowing this direction. Because what happens is that wind, as it's blowing, it has little tiny water particles in there, and that water, when it hits the object, it freezes, and as it keeps moving, it still keeps building up and building up and building up, and it comes to this nice little point. You can see these in when we have fog that comes in, freezing fog. We can see this rime that occurs. Sometimes people will call it Jack Frost. You'll see it on the leaves on fences. It's beautiful stuff. Now, this last image that I have here, I didn't talk about this when we talked about clouds, but I have so many people that ask me about it, I thought I would show it. So what this is a contrail. A lot of people think that this is pollution. This is exhaust from these jets. It's not. What this is that this is heat. So you can see that we have this jet right here. We have air that's coming into the engine, and it heats up, and as it goes back out, it gets really hot, and then it cools down. Well, as that cools down, it gets to that lifting condensation or the dew point, and when we get to that dew point, a cloud begins to form, and we get this nice little contrail here. Interesting fact is that 0.1% of all the clouds that we see on our planet are caused because of airplanes. They're all contrails. Kind of cool stuff. Okay, guys. So this is it. I've done. I hope this works out for you. I'm trying to keep these short and simple. I don't really want to make these all too long because I know nobody likes to sit and watch somebody for over an hour or more. So like I said, I'm going to try to keep these short. Here's your bit about precipitation. You did condensation. Now we did precipitation. Hopefully you know how rain forms, how snow forms. Remember there's two different processes. We have the Bergeron process, which is the cold process, and then we have collision coalescence, which is a warm process. And between those two, we either get freezing precipitation or we get liquid precipitation. And then we get all of those different types of particles that fall out of the air. Okay, take care, and until next time, I'll see you.